Okay, there it is. Okay, so rectangular coordinate system. We've talked about this guy before, but his name was Rene. He's the guy with the really cool hair. And he had that rule of signs where we were counting sign changes. Remember that guy? So his name was Rene Descartes. Wait for it. So, this guy came up with the rectangular coordinate system. He's to blame for all of your graphing woes. Alright, so it says label the quadrants, both axes, and all the ordered pairs. Alright, so we know this guy is the x-axis. Back in the day, they used to call it the abscissa.
Of course they did.
Right? Right? Do you want me to write it down? I'm not going to ever ask you to know it. It's called the abscissa.
Oh, it should be extra credit.
Extra credit. Oh, dang. I'm not writing it down. This one is the y-axis, and that one they used to call the ordinate. So if you ever hear those words, the ordinate. Now, the quadrants are labeled with Roman numerals. Okay? I would like you to use Roman numerals. Do you remember Roman numerals? Okay, so we always start here in the upper right-hand corner, and he's quadrant 1. And we write him with an I. And then we go counterclockwise. I don't know why sometimes we go clockwise and sometimes we don't, but we go counterclockwise. So this guy is quadrant 2. I. And this guy is quadrant 3, I. And how do you write 4 in Roman numerals? IV. Okay, then it says label the ordered pairs. So if we talk about our x's and our y's, who's positive in quadrant 1? Everybody's positive in quadrant 1. So those are plus plus. Okay, how about quadrant 2? Minus plus. X is negative. Y is positive. How about quadrant 3? Everybody's negative. He's the sad quadrant. All that negativity. Man, tough crowd this morning. Okay, how about quadrant 4?
Well, I'm going to go on these more height, so I'll be right back.
Plus minus.
I'll have to dump it back to this.
Okay, you okay with that?
Watch it.
That should be familiar, correct?
Yeah.
Okay. Yes, we'll use that part of it. All right, so number 1 there says, can you graph a line? So let's just have a refresher. So there's 2 forms here. The first one is standard form. Now, we could rearrange this guy, right? But he'll work out nice and pretty if I graph him instead with his intercepts. Does that sound familiar? And if you've had me, I called it the cover-up. Meaning, if I cover up the y, where does he cross the x-axis? Other way. 4x equals 20. 5, so x equals 5. So that would be the ordered pair 5, 0. Okay, and if I cover up the y, or sorry, the x, what would y be? Y equals 4, so that means I have an ordered pair of 0, 4. I'm not going to make you graph lines on your homework. Okay, how about if it was in slope-intercept form? Where do I start? Y equals mx plus b.
-5.
-5. We're going to start with our y-intercept. 1, 2, 3, 4, 5. What's my slope? 3. Up 3. 1, 2, 3. Right 1. 1, 2, 3. Right 1. If you go to the right, you're always right. Does that look familiar?
Yeah.
Vaguely, slightly. Okay, so lines. And then we talked about parabolas. We had two forms. We had that standard form of that parabola right there. How do you want to graph this guy?
Well, I don't know. Actually, can I tell you? Go on my calculator.
Put it in your calculator. I like where your head's at, Blake.
I stuck a little calculator portion of the standardized
Make a T-table. If it's on this, the non-calculator part, make a T-table.
I can just get it wrong. Yeah, that's what I do. I just skip them.
You're making your math teacher cry.
When would you ever be without a calculator? I'm not doing math out in the middle of the woods, so it's just a trash test.
You are. You hear a phone in the woods, though, so you can't.
I'm not graphing parabolas in the woods this time. I really hope I'm not.
Yeah, those would be scary parabolas.
Graph this parabola or you die. I just died.
What? Okay, so let's see. It looks like our vertex here is at -3, -5. One, 2, 3, 5. -4, -4. We like it better when it's in vertex form, right? Because if it's in vertex form, then we can just look at it and say, hey, there's the vertex, here's my slope, here's which way he opens, right? All of those fun things. Think back to chapter 8 when we were doing conic sections. So remember, vertex form is y equals a times x minus 8 squared plus k. So where's my vertex with that bad boy?
It's at HK.
H comma k. So in this instance, -3, -4. Awesome, thank you. 1, 2, 3, 1, 2, 3, 4. And what's my a value? 2. So I'm going to use that as my slope. Up 2, left and right 1. So he's a wee bit skinnier than the last guy. Ooh, are you good with that? You okay? I'm not having you graph lines or parabolas on your homework.
Good.
Sound good? Okay. I feel like we've been on that ship. That ship has sailed. But number 3 there says the standard form of a circle. X squared plus y squared equals r squared, right? Or, if I write them down here, x minus h squared plus y minus k squared equals r squared. So if you look at this guy in letter A, x squared plus 25, x squared plus y squared equals 25, where's the center? 0, 0, right? I don't have an h and a k, so my center is at 0, 0. What's my radius? 5, the square root of 16. I mean 25, Lord. Math. Okay. How about B? I was looking at the next one. 1, -2. Remember, we have to flip their signs. These guys are both negatives, and they're in a set of parentheses with a variable. So my center is at 1, -2. And now what's my radius for this guy? 4, square root of 16. That's really what I meant.
Can we go up to the vertex form of
Yeah, how about that guy? That one?
Oh, it's just
It's just like that vertex form for a parabola. Jillian.
How did you know how to work
These two? I just used that guy as a slope. So I just went up to left and right. Yeah, good question. JJ.
So for number 2,
Yeah.
I tried on my calculator to like figure
The A or B one? Okay. Got it. You just have it set. So I just went
Again, for the first time.
Okay. Questions on circles, parabolas, or lines? Okay, turn the page. That wasn't very much wait time. I asked you if you had a circle or a question, and then I said, okay, turn the page. Sorry.
Oh no. I don't like how much sounds.
So number 4 has the distance formula right there. Does anybody remember what the distance formula is?
It's either x1 plus x2, x that one, x.
Yeah. If you write it.
x2 minus x1.
If you write it out.
Plus. Oh, there's so much. I wrote it on my formula sheet, which is the only reason I remembered it.
Remember that the distance formula comes from the Pythagorean Theorem. And maybe that'll help you remember it. So the distance formula comes from the Pythagorean Theorem. Wyatt.
Why didn't it square root with 30?
So because of that plus sign there, I can't take those square roots and make it just x minus x and y minus y. So that square root there, he's a grouping symbol, which means I got to do everything under it first and then take the square root. Okay? Also remember, think about what the Pythagorean theorem was. A squared plus b squared equals c squared, right? So what this guy's really done is solved it and just taken the square root of one of them, or your hypotenuse, if you will. Okay, so 4 there says, the example says, find the distance from the origin to the point -5, 12. Okay, well, what's my origin? 0, 0. So my distance is the square root of -5 minus 0 squared plus 12 minus 0 squared. Whoop. Okay, -5 minus 0. -5, okay. Square -5. 25, okay. Should I ever get a negative number under my square root?
No.
No, because I'm squaring them. You can't have an imaginary length. I can't have a negative length. Remember, we're doing distance. All right, 12 minus 0 is 12. 12 squared is 144.
It's 13. 160. You don't mind.
169 square root of 169 is 13. Number 5 says, verify that the point root 2 divided by 3 comma negative root 7 divided by 3 lies on the unit circle. Guess we better have a conversation what the unit circle is. It's a circle centered at the origin who is 1 unit away from the origin. Or it has a radius of 1 the whole way around. Okay, well, we had a circle here centered at the origin, and the point, negative 512, was on that circle. And my distance between that point and my circle, my center, was 13, which means that circle had a radius of 13. Well, if it's on the unit circle, my radius, or my distance from the origin to that point, has to be equal to 1. So if it says verify that it's on the unit circle, we've got to take the distance from this guy to the origin and see if it equals 1. Okay, let's try it. Here we go. Is the square root of root 2 divided by 3 minus 0 squared plus negative root 7 divided by 3 minus, yowzer, 0. Squared. Does that guy equal 1? Let's try it. Okay, so if I subtract 0, it's just root 2 over 3. Square the top, square the bottom. Okay, I can do that. Root 2 squared is 2. 3 squared is 9. Negative root 7 over 3 minus 0 would still be negative root 7 over 3. So what's negative root 7 squared? 7, right? A negative squared is a positive, so that guy becomes 7. 3 squared is 9. What's 2 ninths?
Equal 9.
Plus 7 ninths. 9 ninths. Hey, what's 9 ninths? 1. What's the square root of 1? Yay! All right, questions about that? So anytime it tells you verify that it's on the unit circle, what it's really saying is make sure the distance from the origin to that point is 1. All right, number 6 says draw a 45-degree angle in standard position and find a point on the terminal side. Okay, so we talked about this a little bit in the last section. But in standard position means I start with my angle on the positive x-axis. And it told me to draw it positive 45 degrees. So I'm going to start on my positive x-axis and I'm going to go counterclockwise 45 degrees. The nice thing about 45 degrees is they are the diagonal, right? Okay, so there's my 45-degree angle. The terminal side is where we ended up. So on this guy right here, find a point on the terminal side of that.
0, 0.
Okay, 0, 0 would be the vertex.
Much wrong.
We could do,
Much wrong.
I don't know.
How about by drawing a triangle. If this guy's 45 and this guy's 45, that means those two have to be the same. Would you agree with that based upon our 45, 45, 90 triangle? So what's the easiest point to pick? If I go over one and up one, this point would be 1, 1. What's another point on that line? Ray?
172 and 172.
Perfect. 172, 172, right? 2, 2, 3, 3, 4, 4. As long as they're the same.
We can skip 7.
No, you'll like 7. Okay, let's do another one of these really quick though.
That's just a word.
Read letters.
That's just a word.
Let's do another one of 6. How about 135 degrees? Okay, well, straight up and down would be 90, right? Great, here we go. There's my initial side. Here would be 90.
Yeah.
Where would 135 be?
Like 45.
45 in quadrant 2. Okay, so there's 135 degrees. What's a nice, easy point on that guy?
-1.
-1, +1. Are you okay with those?
Yes.
Okay, Griffin's scared for number 7, but it's not horrible, I promise. What that right there means, this is my theta, so that means my angle, theta. That little funky looking E means is an element of, Q stands for quadrant, and then it's got my Roman numerals of 2. So theta is an element of quadrant 2. I want you to think about element as in. Theta is in quadrant 2. This guy right here, the green one we just did, is in quadrant 2. 135 is an element of quadrant 2. My angle is in quadrant 2. So if I said theta is an element of quadrant 4, it would have to be more than 270 degrees, but less than 360. Does that make sense? Or if I would have said theta is an element of quadrant 3, it would be between 180 and 270. Make sense? So a quadrantal angle is an angle where it stops, the terminal side is on the axis. So what are your 4? Tricky. I'm going to say 5 quadrantal angles. 0, 90, 180, 270, 360. Technically, we probably could keep going because you can go around that circle as many times as you want. Okay, so a coterminal angle, those are two angles that share the same terminal side. So we just talked about two of them. They were quadrantals. Which ones share the same terminal side? 0 and 360, right? They're in the same spot. So think about when they get to the same place. So let's do an example here at number 10. It says draw a negative 45-degree angle in standard position. Standard position means it starts on the positive x-axis. Its terminal side is where the number of degrees is. Okay, so here I go. Standard position. There's my beginning. Negative 45 degrees. Remember, if we go up, it's positive. If we go down, it's negative. So if I go here, this guy is negative 45 degrees. Then it said name a positive coterminal angle and a negative coterminal angle. Okay, so if I start here and I go this way in the positive direction, how many degrees do I have to go to get to the same exact place? I heard it. 315, perfect. If I start here, this way around is 315 degrees. Or my angle plus 360, right? How do I get another negative coterminal one though? Okay, well if I'm going to go negative, I've got to start here. But what if I don't stop there? What if I go around like this? I'm going to subtract another 360, right? Yep. Negative 405. And you can keep doing that, right? We could keep subtracting 360 and going around and around and around and around till we get there as many times as we want, or an infinite number of times. Make sense? JJ, do you need to go?
Not yet.
Okay. All right. Questions on your notes? Okay. Let's look at your homework then for both sections. Okay, so if you look at your calendar at the bottom is also your assignment sheet. So on page 11, you're going to do 10 through 54 even and then 60 through 64 even. Some of these should go pretty fast. So 10, it says, tell me whether it's acute or obtuse, and then tell me its supplement and its complement. Like I said, those should go fast. Okay? Through 54. I think on some of these you're going to use the Pythagorean Theorem. 30, 60, 90 triangles, 45, 45, 90 triangles. Yeah, that's where it ends. Then you're going to go over to page 25.
I got an extra.
Okay. And you're going to do 32 through 50. And I'm going to skip all the way to 32 because those first ones are like, graph the line. Which quadrant is it in? So you're going to skip all the way to 32. And start with the distance formula. Okay? 32 through 50 even. 50 has you graph a circle. You can just sketch it on your paper. And then 62 through 88. 62 through 88 is the more tricky stuff. There is a picture at the top of page 28 that is very helpful. Okay? You might want to put a sticky note, bend the corner of that page or something like that because we'll use that one a ton. Okay? It's got nice, pretty angles the whole way around the circle. Okie dokie? Okay, questions? Wyatt.
What's our heading in doing it on paper?
Pardon, say it again?
Are there heading in?
No, you're actually going to still do it on Canvas. Like usual, you're just going to use notebook paper. So, that being said, I have a huge stack of notebook paper over here on the bookshelf if you need any help yourself. I keep a stash of it. Some of it might be wide ruled, so FYI.